Good afternoon. Thanks so much, Kate. Thanks for this opportunity to talk to everyone. My name is Cindy Dowd, and I'm a professor of chemistry at GW, and I've been at GW for about 17 years. And I am the chair of graduate admissions for our master's in chemistry and PhD in chemistry programs. Professor Zismalic, would you like to introduce yourself?
Sure. My name is Martin Zismilic. I'm an associate professor. I'm a deputy chair and director of graduate studies in the chemistry department. And yeah, I think that's about it.
Great. So what we're going to do this afternoon is we're going to talk to you a little bit about the three graduate programs that our department offers. We have, as I mentioned, the Master's in Chemistry, Master's in Environmental and Green Chemistry, and then the PhD in Chemistry. And so we're going to go through those three programs. We're going to talk a little bit about our department. We'll talk a little bit about admissions, and then we'll have an opportunity to talk about to have some questions at the end. So as Kate mentioned at the beginning, we're very fortunate to be located in Washington, D.C. And D.C. is a great place to do science, right in the nation's capital. We have lots of obviously funding organizations as well as research organizations nearby. There are also some other colleges and universities that we closely align ourselves with. And so in general, it's a great place to do science and sort of to think about scientific learning, scientific research, as well as policy in DC. Okay, so whenever we talk about our chemistry department, a few years ago, we had the opportunity to undergo a strategic plan initiative. And so from that strategic plan, we defined as a department our mission, vision, and values. And for all of our talks, we make a point of going through all of these statements so that everybody sort of understands where we're coming from. And it's important to also realize that our students and faculty and staff all sort of believe and subscribe to all of these points. So in terms of our vision, we strive to be internationally recognized as the premier chemistry department for education, innovation, and cross-disciplinary research in the nation's capital. We advance world-class research and education in the chemical sciences to improve global well-being. That's our mission. And then in terms of our values, we strive to accelerate discovery, to improve global well-being, to guide students in their pursuit of knowledge and innovation, to foster an open culture of diversity and inclusion, to promote a collaborative community dedicated to excellence, and to develop effective professionals in interdisciplinary sciences. So all of us sort of keep these thoughts at our forefront in whatever aspect of the department we sort of carry out our research and teaching. And so what you see here is a picture of our home, which is the Science and Engineering Hall, or the SEH. It's about 500,000 square feet, so it's almost a full city block, and it's in downtown Washington, D.C. We're about 4 or 5 blocks from the Capitol or from the White House, and we're in DC's Foggy Bottom neighborhood. It's a fairly new building, and the entire chemistry department is in the building. So all of our chemistry teaching, as well as all of our research spaces, are all in this very beautiful building. And throughout today's presentation, you'll see pictures from all over the building. Okay, so here's two examples, so two lab examples. The building, so it opened, I guess, almost 10 years ago. And as I mentioned, it has all of our teaching and research spaces. That's great from a graduate student's perspective, because if you're many of our graduate students serve as teaching assistants also. And if you're a teaching assistant in the department, then that means that you're in the same building as your research lab is. So that means you don't have very far to go. Our stock room and our instrument suite, everything is all in the same building. If you're teaching lectures, like Professor Zismalic and I both do, we generally have to go outside the building to a different part of campus to teach our lectures because most of the space in the SEH is dedicated to laboratory space. And that was intentionally done to keep all of our labs together. And you'll notice the space is very bright, both with windows, so there's not a lot of natural light, and a lot of lighting. And the idea here is to make the science visible to people within the building and outside the building. and something you'll hear me talk about in just a few slides. These are two more of our labs. The bottom one happens to be my lab. One of the benefits of our department is sort of a low teacher or student to faculty ratio. And the students have very hands-on experience with all of the faculty across our department. And you can see that in the top picture here, whether that's at the lab bench or in office hours or in classroom or just talking about our science. It's very easy to have faculty access. Okay, so in terms of our learning outcomes and our goals, we've agreed as a department, we've agreed on a number of outcomes that we all sort of hope and strive for our students. Our students will attain a level of technical ability and knowledge in chemistry and related sciences to then excel as professionals in their discipline. They'll gain hands-on research experience using technical and problem-solving skills to contribute to their field, develop professional communication and presentation skills, and then be well positioned to obtain employment in a variety of chemistry-related fields. And I'll talk about how each one of these parts of our objective sort of feed into our graduate programs. So some highlights of our programs as a whole. As I mentioned, we have a very low student to faculty ratio with individualized teaching and mentoring. Right now, the ratio is about 3 to 1, so 3 students to every 1 faculty member. We have a close-knit community of graduate students of about 40 to 50 doctoral students and 10 to 20 master's students. And that's with both master's programs combined. And we have a moderate-sized department. We're not a huge department. We're sort of a medium-sized department with 15 research active faculty members. And because of that, we are a fairly close-knit group. It sort of doesn't matter what your specialty is. The physical chemistry folks talk to the analytical folks, talk to the inorganic folks, et cetera. And sort of nice that we all sort of are all in one space and one sort of mindset. And it's this size that promotes our strong connections, both while you're here at GW and then also after you leave, after you graduate. Okay, so we're going to talk a little bit about the sort of nitty-gritty of our programs. And that begins with our courses. And no matter if you're on the master's track or the PhD level, and when I say master's here for the next several slides, I'm talking about the master's in chemistry. We'll talk about the master's in environmental and green chemistry in just a minute. But both the master's in chemistry as well as the PhD programs start with coursework. And so you'll take 5 courses. And those courses are based on 3 what we call core courses plus 2 electives. The core courses are offered by the chemistry department. There's some flexibility in there. And then the 2 electives can be of your choosing and generally have to do with what your research is going to focus on. And those don't have to be in the chemistry department. They could be in biochemistry or statistics or physics or whatever best serves your research purposes. And here's some examples of, well, on the left-hand side, you can see our lobby. So that's a picture of the lobby of the Science and Engineering Hall. But you'll also see some examples of the core courses that our department offers. And it's important also to know that because one of the benefits of being in Washington, D.C. is the ability to take courses not just at GW, but also at what's called our consortium schools. And there are 5 schools that are in the D.C. area that are part of our consortium. And what that means is if you'd like to take a course, but GW isn't offering it right now, then maybe Georgetown is, or the University of Maryland, or Catholic University, et cetera. And you can take a course, and there's a form that you can fill out and have it count for your graduate program in chemistry. And there's no tuition that exchanges that sort of happens in the ether. And then that can count for your PhD. Or your master's, I should say. As I mentioned, one of our values is the importance of communication and communicating your science. And so we weave in several speaking opportunities for all of our graduate students. And for, I think we can all agree that now more than ever, communicating our science is not only important to your own success, but it's also important to explain science to the broader community. So what this looks like is master's students give one 30-minute seminar to the department. PhD students give a 30-minute seminar, usually after their second year of grad school, plus a 60-minute seminar closer to their graduation date. In addition to that, students have the opportunity to go outside our department for a whole host of either poster presentations or oral presentations all over the region, the nation, and sometimes internationally. And so we try hard to allow students to have those opportunities because it is such an important part of their development as a student, and then what they'll carry on with themselves as a professional. And so what I'm going to talk about now is what's called our PhD at a glance. And this is going to be a couple of slides that sort of describes what the PhD program offers sort of at a yearly basis. So when you're a first year, your first semester of your first year, you would come in and then you would generally do rotations in 3 labs. You would figure out who your research director is going to be. That person's going to serve as your advisor for the time that you're at GW. And then you're going to start your courses. Generally, graduate students, and this is regardless of which program you're in, students take no more in the PhD, certainly no more than 2 courses at a time. Master students can take 3 courses at a time. In your second semester of your first year, you're going to form your dissertation research committee. So these are going to be the folks, in addition to your research advisor, that sort of you can go to for questions, and they can help guide you in terms of what what shape your research project is going to take, and they can help you with problems as they come up along the way. You'll also be devising and submitting a document called the Program of Studies, which is just an outline of the courses you plan to take, when you plan to do your 30-minute talk, as well as your 60-minute talk, who is on your dissertation committee, et cetera. So in your second year, you're going to complete your coursework. So you'll complete those 5 courses that you need to take. You're going to give your 30-minute seminar, and you're also going to start what's called your cumulative exams. Start and hopefully finish your cumulative exams. These are exams that are offered monthly in the department, and it can sort of be in an area of research of your choosing. Most people align those exams with what they're studying in their lab. So for example, my students, I have an organic medicinal chemistry lab, and my students generally take the organic cumulative exams. It doesn't have to be that way. That's just the way that it generally works out. And these exams are scored you get one of 3 grades. You get a fail, a pass, or a high pass, or in other words, 0, 1, or 2 points. And the idea is you would need to collect points so that you collect either 10 points in 7 exams or 12 points in 10 exams. And once you collect all those points, then you've passed the cumulative exam requirement for the doctoral program, and you move on. If you don't collect those points, then that's a possible reason for elimination from the program. So in your third year, that's when you do your candidacy exam. The candidacy exam is sort of a mini defense. It's a defense of what your project is going to be. And that generally happens before the end of the 6th semester. And then in your 4th and 5th year, you will complete the 1-hour seminar, your dissertation, writing and its defense, and then you have graduation. Now, it's of course important to understand that research happens throughout all of these years, including the summers, and generally happens sort of midway through your first year. So between your first semester and second semester is when you sort of find a lab home. Okay, and so that has to do, so what I've talked about before had to do with doctoral program. We'll talk a little bit about funding now. So funding, so for the master's students, our college, Columbian College, offers some merit-based grants to some of our applicants. We can also offer grants to encourage some diversity in our student population. Then there are some teaching opportunities for students. They can be TAs in the chemistry department for undergraduate labs and serve as teaching instructors. For funding at the doctoral level, all of our students that are admitted to the program are also given full funding for both tuition and a living stipend. And that package, that financial package, is guaranteed for 5 years. Most often what that looks like is students serve as a teaching assistant for their first 1 or 2 years, and that means that they'll teach in the undergraduate chemistry labs, either general chemistry or organic chemistry, for example. And then after that, generally students are moved on to research funding from their research professor. Obviously, that's going to vary. That can vary a little bit depending on funding levels between different professors. But this is sort of the model that we strive for: is a student to be a teaching assistant for the first 2 years and then taken on to research funding for the last couple of years of their doctorate. Okay, so if you're interested in following up or having any more questions after today's session, you're welcome to contact me as the chair of admissions, Professor Zismalich as the director of graduate studies, or Mrs. Renee Shaw, who's our department office contact. And from that, I will turn it over to Professor Zismalich, who's going to talk about our third program, the Masters in Environmental and Green Chemistry.
Okay, thank you, Cindy. We're going to be answering the questions on the Q&A chat as they come, so don't get impatient. Whenever we get a chance, we're going to answer your question. And anyway, so the Masters in Environmental and Green Chemistry is a little bit different from our regular Masters and our PhD program. It's kind of a separate program than the other two. It has its own requirements and its own courses, and you know, it's going to be a little different what we're going to see here. First of all, it has a mission, which is essentially advance the training of individuals in the physical science that are needed to face the environmental challenges of today, and also prepare students for careers in the industry, government, and non-governmental organizations, also related to the environmental challenges that the world is facing. The learning outcomes is going to be to understand and assess environmental impact of human activity mostly, develop solutions for the effects of pollution and chemical hazard, also the design of new chemicals with less or minimal environmental impact, and also, as Cindy mentioned, communication is always a very important factor in graduate studies. Okay, how to communicate to a non-scientific community or a policy community the scientific findings. As you can see, the sustainability and green jobs market is growing very, very, very quickly. So this is these sources from LinkedIn, and you can see what is the hiring of green jobs since 2016 to about 3 years ago. Okay? And green jobs are growing very rapidly. The program consists of 30 credits that can be completed in 2 years. And instead of having 5 core courses as in the PhD and the regular masters, you are required to take 6 core courses, and each course is 3 credits. Okay? So essentially, you are taking 18 credits of core courses. The core courses that you're required to take are environmental chemistry of waters, air, and soil, environmental and ethical chemistry, energy and environment, green industrial chemistry, chemical toxicology, and safer chemical design, and then a capstone course, which I'm going to talk about in more detail in a minute. Okay, so the capstone course is essentially where you bring all your training together into a project that then you're going to present into a live audience of, people from academia, the industry, and non-governmental organizations. So as examples of the partners that we had for the capstone projects in the past and in the present are government agencies like the Environmental Protection Agency, the World Health Organization, and the United States Geological Survey. Also, we partner with non-governmental organizations like the Environmental Defense Fund, Environmental Working Group, and others. We also partner with private sector organizations like Seventh Generation, Dow, DuPont, which is up the street from us, essentially one state over, and also academic partners. So we have many partners where our students work for their capstone project. Examples of recent capstone projects, I think these are just from the last year, if I'm not mistaken. You can see that they fall all over different areas. They are not just chemistry in a laboratory, but they include environmental justice and equitable distribution of green chemistry, development of safer, waterproof, breathable textiles. That's an application to industry. And then obviously environmental monitoring, like the microbial degradation of PFAS. So capstone projects could be all over the place depending on the interest of the students. And so it's not predetermined. That is something that you discuss with your academic advisor at the moment, and you plan your capstone project way ahead of time. So in addition to the 6 core courses, you have to take 12 credits of elective courses. That's usually 4 courses, but sometimes you have to keep in mind that some of the courses have only 2 credits or 1 credit, so you might need to take more than 4 courses. But most of our courses are 3 credits, which means that you need to take 4 elective courses. Those courses can be from the chemistry department. It can be from the GW School of Public Health, from the School of International Affairs, from the School of Public Policy and Administration, Engineering and Applied Sciences, Data Science, Computer Science, or School of Management. And the way that you plan your elective courses depends on your interests. Okay? If you want to have a more or a stronger chemistry background, you will take those courses from the Department of Chemistry. But if your interest is more in public health, you take them from the public health school. Or if you're more interested in policy, you can take it from the public policy and administration school. So that's how you decide those electives, depending on what your career aspirations are. Okay? So once you complete your core courses, then you take your courses based on your career aspirations. As Cindy mentioned, we have a consortium of schools in the Washington, D.C. area, and those electives can be taken not only from GW schools, but they can also be taken at Georgetown University, University of Maryland, and I don't know why we haven't added here, American University, Howard University, and George Mason University. Okay? Those electives need approval from your advisor, but students can choose from a whole variety of courses for the electives. And that's one of the great advantages of being in the DC area, that you have lots of options to choose your career path. Here are some examples of the elective courses that you can take. As I mentioned before, some of them are hardcore chemistry, like organometallic chemistry and catalysis, advanced organic chemistry, chemistry of inorganic materials, molecular spectroscopy. That if you want to have a very strong chemistry background and your aspiration is to work in a chemistry lab after graduation. But you can also take courses that are more in the direction of policy, if that's what your interest is, or also in the sustainability area, or in the public health area, or in the economy area. There is a whole selection of courses that you can take as electives. And again, that depends on what your career aspirations are. We have education partners like Sustainable GWU. That's another program at GW that works on environmental and sustainability issues. There is Beyond B9, which is an organization that focuses on green chemistry education, and they try to promote the insertion of sustainability and green chemistry into the chemistry curricula. And also organizations like Molecular Research and Design and Sustainable Scientists. And all those are our partners in this environmental and green chemistry program. Usually during the summers, not usually, during the summers, we do not offer courses, but that's when students can explore internship opportunities. And the DC area is a great location for internships because you have essentially representations from all the possible NGOs. You have all the governmental departments in DC, and you have representations from many industries in the DC area. So if you're looking for an internship during the summer, DC is the best place to find an internship. And not only our grad students do internships in the summer, also our undergrads do internships during the summer. If you're interested in research, we have mostly 4 groups that concentrate on environmental chemistry. Those are the Miller Research Group, the Costal Research Group, the Vauchkova Research Group, and the Pincus Research Group. And those groups of that are chemistry professors, they concentrate on environmental research. And that's for students in the environmental and green chemistry masters who are interested in laboratory research. For financial aid, there are different opportunities. Columbian College offers fellowships that help to offset the tuition cost. These are not full scholarships, so they just help you to pay the tuition, but they do not cover full tuition. And so that's just one way to offset the costs of the studies in the environmental and green chemistry program. Also, you can apply for a teaching assistant job in the chemistry department. Those jobs are not guaranteed, but are as needed. In some semesters, we need extra teaching assistants. So if you are in the program, you're welcome to apply for those jobs, but they are not guaranteed. And also you can find other jobs around campus, and those are listed in this website, which is part of GW. So some students end up working in the library, others end up volunteering in some lab and washing dishes, stuff like that. So there are many things that you can do to make some extra money to help you offset the tuition. But we do not offer full scholarships for the environmental and green master or for the master in chemistry. There is an office of graduate student assistantships that are, it's centralized in GW. That's where you can find other funding opportunities. And that's the location and the email where you can contact if you have more questions about how to help you offset the tuition and living costs of DC. What happened to the students that graduate from our environmental and green chemistry program? And these are some examples of where our students have ended after graduating from the Masters in Environmental and Green Chemistry. Several students end up working at the Environmental Protection Agency or the American Chemistry Council. They work from some NGOs like Sustainable Building Partners, Energetics in Clean Energy Consulting, and others decided to go to law school after getting the master's in environmental and green chemistry. So we have some students that went into Vermont Law or Georgia State University College of Law. What are the next steps? If you are interested in the environmental and green chemistry program, you can join our LinkedIn group. You can join the GW Alumni Network or connect with other alumni, where you can connect with other alumni from the program and ask them questions. You can explore other GW resources like the Sustainability Initiative or Planet Forward. And also, you can start thinking about what is your career aspirations. Okay, do you want to end up working in a lab? You want to end up working in policy, business, education, administration, public health, etc. Okay, so that's a good next step if you are interested in the environmental and green chemistry program. And with that, we thank you for coming to our presentation today. And I think we have a few minutes to answer more questions.